So now we are going to discuss about zero order reaction. So zero order reaction. So means so the chemical reaction in which the rate equation, otherwise the reaction rate, the sum of the concentrations of the reactants is called as zero. That is not original important. So the chemical reaction in which the rate of reaction is not depending on the concentration of reactants. Suppose you take A gives rise to products. See, suppose initial. So at initial means starting, you take A concentration. So this is 0. After some time, some amount of reactant convert into product. So that is A minus X. This is X. So what is the rate of reaction? So reaction rate equal to minus d of A concentration by dt. That is directly proportion to here A power 0 you put. So that 0 means the rate of the reaction is not depending on the concentration of A. Suppose you take this minus dA by dt equal to proportionality constant, you take k0. So that is a power 0. A power 0 nothing but 1 only. So here k0 you called as 0 order rate constant. K0 is called as 0 order rate constant. Next, K0 units. So K0 units means this is concentration by time. So concentration means mole per liter by time. So time inverse. So you can take. Next, suppose you can tell a graphical manner. So graphical manner means you take one x-axis, y-axis. So on y-axis you take a rate. On x-axis you take a concentration. So what is the zero order? What happens? Whatever the concentration you increase, the rate value is same. So that means the graph is coming like this. So concentration versus rate of zero order, you are getting straight line. It is parallel to the x-axis. So one more important. So now, so we are getting minus dA by dt equal to k0. So you expand. So that means minus dA. Minus dA, you take k0 into dt. See, this equation is explaining what? Differentiation. Differentiation means a small portion of the reaction. Suppose you take dA equal to minus k0 dt. For a complete reaction means take integrations on both sides. Above equation explains a small portion. Small portion of the reaction only. That is called as a differentiation. For complete reaction. For complete reaction. So you take integration. So that means integration of dA equal to minus k0 into dt. See, Starting only we discussed at a particular time the concentration is what? A minus x. So this is a minus x value equal to minus k0 integration of dt equal to t plus c. This is next. So already starting we discussed a gives rise to products. So starting is what? At starting point t equal to 0. It is a concentration, product is 0. After some time a minus x, this is x value. So you want to find out c value means at t equal to 0. So t equal to 0 means what? Starting. At t equal to 0 value. What is the x value? X is also 0. You substitute here. So a minus 0 equal to minus k naught t plus c. So t value also 0. So that implies c equal to, so that is a value. So you take equation 2. So from 1 and 2. So from 1 and 2. So what happens? A minus x equal to minus k0 t plus c equal to a. So this is the complete equation. So now it is looking like in what way? So you take a graph y equal to minus mx plus c. Next, sometimes they will give a minus x value. They are given as a, otherwise r also. Next, a is given. So minus k0 t plus a concentration. So that is taken as a naught. So different books. So some books this value is given as R. This is given as R naught. So anything you can take. So y axis. So x axis, y axis. On y axis you take a minus x value. Next x axis you take time. So then what happens? It is a negative slope. So from top to it is coming down. So the slope equal to m equal to tan theta, that equal to k naught minus k naught. So next, half-life. Half-life of zero order reaction. So starting we are taken a gives rise to products. So t equal to 0 you are taken as a. Next t equal to t. This is what? A minus x. This is x value. Next t equal to t of. So a minus x also a by 2. X is also a by 2. So what is our equation? That is a minus x equal to k0 t minus k0 t plus a. So t equal to t of. So t equal to t of you put a minus x equal to a by 2. So that means here a by 2 equal to minus k0 t of plus a. So that means t of k0 t of you take this side, a by 2 you go that side. So k0 into t of equal to a minus a by 2. So that is a by 2. So t of 0 order equal to what? A by 2k naught. Next, here important is what? So try to remember the rate of 0 order. The rate of 0 order is not directly proportion to initial concentration, but T of 0. T of zero order is directly proportion to initial concentration. So based on this also, you can take one graph, x-axis, y-axis. So x-axis, you take concentration, otherwise time, T of values, concentrations. Suppose here concentration value you take, here T of value you take. So then what happens? See, if you are increasing the concentration, the T of value also increases. So that's why it is going through the origin. So according to T of, you are getting one graph also. Next, half-life. Half-life of zero order reaction. So starting, we are taken A gives rise to products. So T equal to 0, you are taken as A. Next, T equal to T. This is what? A minus X. This is X value. Next, T equal to T of. So A minus X also A by 2. X is also A by 2. So what is our equation? That is A minus X equal to K0T minus K0T plus A. So T equal to T of. So T equal to T of, you put A minus X equal to A by 2. So that means here A by 2 equal to minus K0 T of plus A. So that means T of, K0 T of, you take this side. A by 2 you go that side. So K0 into T of equal to A minus A by 2. So that is A by 2. So T of 0 order equal to what? A by 2K naught. Next, here important is what? So try to remember the rate of 0 order. The rate of 0 order is not directly proportion to initial concentration, but T of 0 order is directly proportion to initial concentration. So based on this also, you can take one graph, x-axis, y-axis. So x-axis, you take concentration, otherwise time, T of values, concentrations. Suppose here concentration value you take, here T of value you take. So then what happens? See, if you are increasing the concentration, the T of value also increases. So that's why it is going through the origin. So according to T of, you are getting one graph also. Next, examples. Examples of zero order reaction. So one is light reactions. So H2 plus Cl2 gives rise sunlight. So you are getting 2HCl. Suppose H2 plus Br2 in the presence of UV light, you are getting 2HBr. So light reactions are also zero order. Next, any heterogeneous reactions. Heterogeneous reactions means you take NH3. 2 moles of NH3, only molybdenum. If you take iron means ammonia formation is more. Only molybdenum means it is dissociated. So N2 plus 3H2. So that means ammonia is gas, molybdenum is solid. So that is what heterogeneous. So heterogeneous reactions. Suppose NO plus O2. That is, you take platinum and the presence of platinum. So NO is gas, O2 is gas, platinum is solid. So it is heterogeneous reaction. So 2NO2. So this is also. Next, already we seen any reactant. Any reactant, if we take excess, so already we discussed, then what happens? Rate is not dependent, depends on concentration. So any reactant in the reaction, if you take excess amount, then the rate is not dependent. Rate is not depends means that is a zero order reaction only. Now we will discuss first order reaction. See, the chemical reaction in which the sum of the powers of reactants, so in the rate equation, is equal to 1. So then you called as a first order reaction. See, suppose starting A gives rise to products. So T equal to 0. Here, initial concentration A, product is 0. T equal to T after some time. So it is A minus X. Here X amount of product is available. So T equal to T off. So that means that the amount of A, initial amount, is converted into half of that time you called as a T off. So that is A by 2. So X value is also A by 2. So this is basic. So here the rate of the reaction means minus dA by dt is the rate of reaction, is directly proportion to, so initial concentration. So that is A, starting reactant. Suppose here how much dA value is what? A minus x, minus A minus x equal to proportionality constant, you can take K1. So otherwise for units you write down first. So here equal to minus dA by dt equal to K1 into concentration. So K1 is the first order rate constant. So K1 is first order rate constant. So the K1 units. So K1 units you want means here what? This is concentration minus concentration, whatever it may be, by time equal to K1 into, here also A is the concentration. So concentration cancel. So the K1 units. So K1 units equal to 1 by time. So otherwise time inverse. So time inverse, instead of time you can put seconds, minute, hours, years also. So this is one important. So now, so write the integrational equation. Integrational equation means dx by dt equal to K1 into A concentration. So at a particular time, A concentration is how much? A minus x. So dx by dt equal to K1 into A value. So A minus x. So here this reaction, so x values one side, t values one side you take. So dx by A minus x equal to K1 into dt. So this reaction differentiation means a small portion only is explaining. So for complete reaction means you take integrations. So integrations on both sides, dx by A minus x equal to K1 into dt of integration. So the integration of 1 by x dx, that is what? Log x. So ln a minus x. Ln means natural logarithm. So x has a negative charge. So you put a minus equal to k1 into integration of dt t. So plus integration after you will get one constant. So that is equation 1 you can take. So already we know at t equal to 0, at t equal to 0, x value is 0. So that means minus ln a equal to k1 into 0 plus c. So that is 2. From 1 into 2, from 1 into 2, what is that? Minus ln of a minus x equal to k1t minus ln a. So further expansion. So further expansion is what? You take minus that side. So otherwise ln a you take this side. Ln a minus ln a minus x equal to k1t. So this is log a minus log b. So ln a by a minus x equal to k1t. So this is y equal to mx type, one formula. Next, otherwise minus you take that side. So minus you take that side means ln of a minus x equal to minus k1t plus ln a. So this is y equal to minus mx plus c. This is one more. See now, so for this you take a graph on x-axis, y-axis. Y-axis you take ln a by a minus x. Next x-axis you take t. So y equal to mx means it is moving through the origin. So what will be the slope? Slope m equal to k1. See here one more. So you take log, log of a by a minus x equal to, so log means what? Ln equal to 2.303. 2.303 log of a by a minus x equal to k1t. Suppose log of a by a minus x equal to k1 by 2.303. So here also you can concentrate x-axis and y-axis. You are taken log a by a minus x and y-axis t is here. So this is also slope. But slope m equal to k1 by 2.303. So you must concentrate on the graph. What is that? They are mentioned ln means natural logarithm. Your slope is k1. If they mention log a by a minus x, then your slope will be k1 by 2.303. In examination, what they are given, natural logarithm or base 10 logarithm, you must concentrate and you write down this one. Next, here you take this one, this graph x y. So it is a negative. Y means ln of a minus x. On y axis you take, x axis you take time t. So it is a negative slope. So it is coming down. So that means what? Negative slope. The slope is m equal to minus k1. Next, it is intercept. The intercept value is ln a. See, here ln means natural logarithm. You can convert into base 10 logarithm. So that means 2.303. You take this side. So then what happens? The log a minus x equal to minus k1 by 2.303t plus log A. So this also you take a graph. So x-axis, y-axis. Y-axis you take log of a minus x. Next, t you take this side. So then it is what? Negative slope only. But the intercept is what? Log a. Next, the slope is minus k1 by 2.303. So you see the difference. Natural logarithm they are given means slope is k1, but log base 10 they are given means that is k1 by 2.303. So in examination what they are mentioned, natural logarithm or log logarithm, you must concentrate. Next, half-life. So half-life of first order. So which one you called as a half-life? The time required for half of the initial concentration become as a product, that is a half-life. So here, so already at t equal to t of, at t equal to t of, a minus x value is also a by 2, x is also a by 2. Already in the equation we are discussed that one. So here log of a minus x, that is what? A by 2 equal to minus k1 by 2.303 plus log a. So you take this is this side and that one. So k1 by 2.303 equal to log a minus log a by 2. Log a minus log b. So that is log a by b. So that is log a by 2. So that means k1 equal to, so 2.303. So here that is what? K1t. So here a by 2 means t of. So here also t of. So t half equal to 2.303 is coming to this side. A and a cancel. You are getting a log 2 divided by k1. That equal to, so this value 0.693 divided by k1. So the important t of first order equal to 0.693 by k1. So that means what? So here, so one important point we can write for first order, the rate of first order. The rate of first order is directly proportional to initial concentration. So the T of first order is not depending on A. So this is one important. You can compare with zero order also. The rate of zero order is not depending on A. But T of zero order is directly proportional to A. So exact opposite. Zero order, first order. You must concentrate. In the problem, they will ask this only. Otherwise, directly. So which of the following T of order is directly proportional to A is not directly proportional to initial concentration. So that you can. Next here. Examples. So examples of first order. So that is bacteria growth. So bacteria growth. Next, radioactive decay. So radioactivity. So means all nuclear reactions. It is a first order reaction only. Next, sucrose. Sucrose, otherwise benzene diazonium chloride. Sucrose hydrolysis or ester hydrolysis. So all are coming under first order reactions only. So whatever we are discussed, this is completely CET point of view only. So direct they will ask which of the following is first order reaction, what is the unit, what is the formula, what is the graph, like zero order, first order, they will ask the questions. Next, suppose in radioactivity, if you want means one you can take. Suppose 1 gram of substance is there. So 1 T of it become as 1 by 2 gram. So next T of it become as 1 by 4 gram. Next T of it become as 1 by 8. So that means so 1 by 2 to the power of 1, 1 by 2 square, 1 by 2 cube. So T of 1, T of 2, T of 3. So in radioactivity, they will, in what way they will ask, after 3 T offs, how much amount is remaining? So how much amount is remaining? That means 1 by 8 is remaining. How much is consumed? Consumed means 1 minus 1 by 8. That is the consumed. So how much amount is consumed or disappearance? That equal to 1 minus 1 by 8. That is 7 by 8 amount is consumed. So instead of 1 gram, they will give 100 grams. 100 grams means 50, 25, next 12.5, like that you can move. Otherwise, initial concentration A they will give. So A by 2, A by 4, A by 8, so like that. N T offs are happened. How much is remaining means 1 by 2 to the power of N you can put. See, 2 T offs means 1 by 2 to the power of 2. 3 T offs means 1 by 2 to the power of 3. N T offs means 1 by 2 to the power of N. So like that you can take the formulas.